Hello, this is NAE Grand Challenge Group number 19, and our team consists of Christian Bernal, Natalie Crow, Michelle Medellin, Nick Mestespi, and Victoria Pride. Our NAE Grand Challenge is to engineer the tools of scientific discovery. Hope you enjoy. As a group, we decided it would be interesting to do our project on Mars. Mars is the fourth planet in the solar system. Millions of years ago, Mars was habitable, maybe not by humans, but it could sustain human life. Now, Mars lacks a magnetic field. Its average temperature is around -55 degrees Celsius. Mars' atmosphere is mostly made up of carbon dioxide and many more. But what gives scientists hope is the fact that Mars has water, even if it's in the state of a solid. Mars days are measured by sols, which compared to Earth, a sol is 24 hours, 39 minutes, and 35.244 seconds. We as a group were able to find Mars atmospheric data. The data consists of the maximum and minimum ground and air temperature in degrees Celsius, as well as the pressure in pascals. From the data, we decided that the purpose of our code would be to give the user the opportunity to decide what he or she wants to view in terms of atmospheric data, and whether or not he or she wants to convert certain data into different units. For example, if the user wants to convert the temperatures from degrees Celsius to degree Fahrenheit, he or she can do so. This code is advantageous to engineers in the sense that they can manipulate it in various manners. They can use it to compare Mars atmospheric data to that of Earth, and from there make determinations of whether there is a possibility for Mars to transition into Earth. Engineers could further use our code to view which sols the temperature in Mars is higher or the pressure is lower to determine a pattern of sols when they can send a rover. The possibilities are endless. The goal of our code was for it to be manipulated in extensive manners, and as a group we believe we were able to achieve this by making conversions of units and allowing the user to view the atmospheric data for as many sols as they wish, as well as graphs of the atmospheric data.
For the first part of our algorithm, we needed a code that would trim down the NaN values from the raw inputted data. This would work by scanning from the bottom to the top rows of the input data, and as it went through all the columns of the row, if it found a NaN value, it would immediately make the entire row null, and it would break, causing it to go on to the next row. It's very important that it went from the bottom to the top. That way the value of the row that it's at would stay consistent, as opposed to if it went from top to bottom, then as it deleted rows, it would become shorter. Next is unit conversion. It begins with asking what units you want the data to be converted to. We chose some of the most common units of Celsius, Fahrenheit, and Kelvin. If a unit other than Celsius is chosen, it will multiply and add whatever values it needs to columns 2 through 5 for the appropriate unit. For pressure, if pascals are chosen, the data is left alone. Otherwise, it is multiplied by the correct multiplier to get to the correct unit that it needs. For individual days, if the user selects yes, they are prompted to enter a day from the first viable sol to last viable sol. This is done because if we had a list of either all the viable sols or all of the inviable sols, then it would have been too cumbersome and too difficult to use. After selecting a sol, a find function searches for the row where that sol is from the first column. This position is stored so that it can be used later. All of the data for that day is printed onto a console, because having a menu to look at each individual piece of data would be cumbersome and non-user friendly. After individual days are viewed, the user is directed to a menu that asks what data they would like to view graphed. These graphs plot the sol versus whatever the chosen data is, as well as marking the viewed days with the blue marker. It should be noted that the correct units are projected to the axis labels of these plots. Finally, the program exports an XLS file of the converted data for whomever is using the program. As for some of the setup of the code, originally we had it to where you'd have to ask for the individual data per day, So you'd have to request for the minimum ground temperature, the maximum ground temperature, pressure, and everything else individually. Aside from this, originally our code was a little chunkier, but we streamlined it so it was a nice simple flow to where it went from viewing the individual days to viewing the graphs. Menus were also used as opposed to manual typing entry for simplicity and ease of use.
For our first test case, the user starts the program by selecting degrees Fahrenheit, which converts temperature values from Celsius to Fahrenheit. Next, the user selects units of PSI, or pounds per square inch, for the display of pressure values. The user is then asked if they want to see data for an individual sol, and they choose yes. The program allows a user input for sols 10 to 400, and the user inputs 21. This outputs maximum air temperature, minimum air temperature, maximum ground temperature, and minimum ground temperature in degrees Fahrenheit, and outputs the atmospheric pressure in units of PSI. The user selects the choice No in the menu asking if they would like to view data for another individual sol, and then allows the user to choose a plot to view all sol data. The user selects to view the plot maximum air temperature, and the plot is displayed.
For this test case, the user selected Kelvin for the temperature and the pressure to be converted into pascals. The user wants to see day 6, but then the program will respond by saying there is no data for that day, so the user has to enter a new day, and the user selected 127. So then the output will be the max air temp, the min air temp, the max ground temp, and the min ground temp, all in Kelvin, and will display the atmospheric pressure found for that day. Then the program will ask the user again whether or not they would like to see another day. The user selected no. So then the user wanted to check out a graph, and the user selected the pressure graph, and then the user wanted to see another graph. So the user wanted to compare the pressure graph with a max ground graphs. So for this test case, the user would try to exit out of the menu. If the user tries to exit out the menu will reappear continuously until the user has selected an option, and this goes for all other pop-up windows.
This code can be used by future engineers who want to develop scientific equipment for Mars. Some of the scientific equipment could include satellites or weather balloons. The temperature and pressure data provided will allow the engineers to easily see what conditions on Mars are ideal for them. And if they want to see the information in specific units, this code will help them to do this quickly and efficiently. The engineers also have the option to manipulate the code so that they can input data from another planet or other temperature data from Mars. One of the limitations on this code include not being able to convert the data to different units multiple times in one run. The code also doesn't allow for the user to compare data to Earth or to have the option of not seeing a graph.